Welcome back, science enthusiasts. Have you ever wondered how can we save Earth if an asteroid collision was imminent? One solution would be to bomb the asteroid into tiny pieces. What if, for whatever reason, we can't bomb it? Let's just assume we can't bomb it because it's too big. What can we do then? Let's first get into the science of collisions. For a collision to happen, there are two basic requirements. Number one, two things must be on the same spot in order to collide with each other. Number two, they must be on the same spot at the same time. This is very important. Let's say you were jogging in the park and a child fell on the track spontaneously. Would you collide with the child? Well, if the child fell on the track a few moments before you were on that exact spot, you simply wouldn't hit the child, because you would have already noticed the child. Similarly, if the child fell after you passed through that spot, you wouldn't hit the child either, because you would have already passed from the point of collision. So, the collision could only happen if you and the falling of child happens on the same spot and at the same time. Now, let's go back to our scenario of an asteroid hitting Earth. Imagine an asteroid the size of Eiffel Tower is moving towards Earth. That's a big-ass asteroid. Now we already know that Earth too is moving around the Sun. So, if the asteroid passes from this location a while after the Earth passed the point of collision, it will not collide with Earth at all. It has to be on a different path from Earth's current position to hit the Earth. It has to move in a particular direction at a particular speed. If it messes with either of the two, it will not collide with the Earth. We also know that there are other planets in the solar system. Some are smaller than Earth and some are larger. Like Jupiter, which is way too massive as compared to other planets. So Jupiter has a stronger gravitational field than other planets. So, if asteroid moves towards the Earth in the perfect position and perfect speed, still Jupiter's gravitational field could alter its path, pulling it towards itself. Although it might not be able to completely stop it, but it can change its direction. And that's all the Earth would need. Even 1 degree deviation in the direction could save Earth from the collision. Okay, let's just assume that the asteroid is moving in such a way that Jupiter's gravity will only make its direction more precise towards the Earth. What can we do then? We can bomb it, of course. Wait, didn't we say earlier that the asteroid was too big to destroy with bombs? We did. But we don't have to destroy the asteroid in order to save Earth. We just have to bomb it in such a way that it changes its course. Even half a degree of tilt in its direction will do the job. By the way, do you know that Earth is hit by 17 meteors every day? Wait, you didn't see it in the news? You didn't see it in the news because they never landed on the Earth. Most of the meteors are burned to ashes in the atmosphere. So, we discussed how we can save the planet from an asteroid by not being at the same place at the same time. Have you ever wondered space objects are mostly spherical in shape? The secret lies in the formation of planets. Heavier molecules keep pushing towards the center of the planet because of its gravity. Eventually, heavier ones end up in the middle, while less dense ones form the outer layer. One thing we observed in all this is that when you keep pushing something inward, like when you crumble a paper, it eventually gets a spherical shape. That's why planets and stars are all spherical. Nevertheless, let's keep rolling. Let's talk about a situation that correlates our asteroid collision theory. Let's just say we have uncovered the secrets of the universe and we have developed a device that could help us time travel. Say you time traveled one day back. When you get out of the device, you'll instantly die. Why? Because the Earth is moving around the Sun. In 1 day of time, it would have moved a little further in space. So when you land exactly at the same place the Earth was before, you'll land in empty space. Okay, so let's say I go back 1 year, at the exact same time when Earth was here. Will I land where I took off from? No, you'll land on empty space yet again. Why? Because the sun is also moving. It is travelling around the Milky Way galaxy. So when you time travel, you have to compute the distance Earth would cover in X amount of time in order to land on Earth. It must cover both Earth's travel around the sun and the sun's travel around the Milky Way galaxy. That's too complicated for me, though. Let's end it here. You can ask your space-related questions in the comments below. We will definitely answer those. I'll take your leave until next time.